Hello everyone, welcome to POC channel. Today we are going to see an interesting case about OpenCV. OpenCV is in computer vision for grayscale and edge detection. The objective of this proof of concept is to explore OpenCV features. OpenCV is an open source computer vision and machine learning library which contains many optimized algorithms. These algorithms can be used to detect and recognize faces, identify objects, classify human actions in videos, track camera movements, and track moving objects. Now, beyond that, computer vision can be used in terms of quality checks in the manufacturing units. Now, at the end of the manufacturing, the objects can be verified for the precision and size. Of course, human intervention is necessary after that. We have a lot of steps involved in this process. Read an image, display an image, shape of image, save an image resizing, convert image to grayscale, Gaussian blurring, cropped image rotation, edge detection, and summary. About the OpenCV, computer vision is a very huge library. We have a lot of libraries available in the internet. We are going to see some of them today. This collab is a very useful place where you can try these and then execute on your own. To set up the collab and how to create an account and all that, watch our other videos in our channel to how to set up collab. Now I'll be start showing you how to start the Google Drive, and then we can keep going. Before going deeper into the computer vision, I'll show you what are all the computer vision libraries available today. If you go to Google and then search for computer vision and then go to their release documents, you will see a lot of options. See how many modules they have, like core functionality, image processing, image file reading and writing. And these are some of the one we are going to see today. They have a lot of extra modules for so many things, including the 3D objects and all of that. So I'll go back to our POC and show you, how to mount the Google Drive. So step one in our POC, you need a space to store, and the images which you are processing in your collab. So I am setting up my Google Drive to be connected with my collab so that the image I'm trying to process can be taken from there. At the same time, images I'm trying to save can be stored in the drive. So I'm mounting the Google Drive first. So you can see google.collab import drive, and you are trying to mount the drive, and you need to provide your base directory. And then if you click on run, it'll say, okay, it is the drive already mounted because I have did this already. So it is trying to mount again. So now the drive is mounted. We need to import the necessary libraries for the computer vision. The important library you need to import is CV2. So it's basically a computer vision 2. So once you add these lines and then execute this, so the following libraries will be imported into your collab. So now these libraries are ready to go, and we can start with our step 3, read image from Google Drive. So I have kept an image under my Google Drive, which is named as flower.jpg. So you can give under any path. However, the core path need to be defined in your previous step in order to collab to detect that folder. And then once you have kept the image, so the first step is to read image from the Google Drive. So you need to read the image and then put it in a variable, which is image variable I'm using. So when I execute this, in the image variable, this particular image is being loaded, and you can see a green tick mark here. So now we are going to display the image which we have loaded. So I'm displaying an image. So you can say, CV2 image show of image. So basically you're reading that variable again, and that's a function. First function I'm using CV2 underscore image show. So now I can see the image which I have from the Google Drive. So if you go back to the Google Drive, you can see this is the image I am using for my POC. So we have seen how to display an image. Now we are going to see what is the shape of the image. We have another function. So I'm printing the image dot shape first, and also I am getting the height and width of the image, and I'm printing the same here. So if I execute, you can see the shape of the image is 793 1203. So you can see height, width, as well as what is the height and width. It will be separately printed. So now you understand, you are picking up some random image, and you need to instruct the computer vision saying, okay, this is my height and width of the image which I'm going to use for my POC, so that the other functions can understand what is the dimension of the image. That's not enough to the computer vision. You need to give more precisions to it. So for that, we are using a multi-dimensional array of images. So I'm using in another functions. We are printing an image type as well as image matrix. So this image matrix is a several multi-dimensional matrix it generates, and then gets feeded into the Colab for the current POC processing. So I'm running this, so you can see the multi-dimensional image matrix is being expanded, and it is now stored in the Colab. So this particular multi-dimensional numbers will be used for our further processing of any of our functions. So now I'm going to save the image. So first I am using cv2.imWrite. So I'm writing this image to the drive. So you can see I'm giving a new file name here, new image.jpg, image, reading from the variable again. So you can, once I execute this, you'll say, okay, true. So which means this particular image we are using is being saved again in the drive in the new name. We'll go back there and then see if it is saved in the new image.jpg. So I'm going back to the drive. So now you can see new image is being saved. So let me refresh this, and you can see it's me. Just a moment ago, this image is saved, and it is exactly saved in the JPG format which you recommended. So the additional options here, some people requires, okay, I want to save this image in a different format. PNG is another standard format. So you can basically use the same command, cv2.imWrite, and then say image.png instead of JPG. So if I run this one, so it says true. So if I go back to my drive, I would most probably see the second image which is saved in the PNG format. You see, now there is another image which is just now new image.png is saved by me. So likewise, you can use any format you like with the same command, same function. So next is the image resizing. So you can now play around with this image, because you have a capability of making this bigger, smaller, however you want. For now, I am taking the half and bigger two variables, and then I'm using a cv2.resize function, and I'm passing the image dimension here. The original height of the image is 1206, and original width is 1604. So I am trying to resize this height and width from 1206 from 1604 to something 600 by 600, for example. And then this is like making it almost the half the size of the image. Then I am making it bigger. So I am making this 1000 by 1000. So it's like from it was 600 before, now I'm increasing it to 1000 cross 1000. So and then I'm saying CV2 image show half of, and then I'm saying CV2 image show bigger of. So which means first I will try to show the half the image which I'm trying to create, and then I'll show the bigger image which I create. So just for indifference, I'm running this now. So I can see the images are generated here. To see the difference, you can go back to the previous image, see how big is this. So now I'm coming back to the current command we ran. So you can see the image size, right? So first you can see the smaller one, which is half the size. See how small it is, 600. And then the second one is the bigger image, which is 1000 by 1000. So likewise, you can play around with these dimensions. The think about it, the multi-dimensional array which you generated in the past is actually helping you to generate these in various dimensions which you like. You cannot imagine how many combinations you can make. It's like endless. Similarly, how can we convert this image into a grayscale? Colors are basically a lot to tell. Color has a lot of properties. You need to instruct to the computer. It's very hard, and also it's like a complex way of explaining somebody this is what the image is all about, right? So rather, what we can do, we can instruct in computer vision saying, okay, this is the grayscale of that image. So what you are doing, you are ultimately reducing the complexity to understand the mission easily, right? The computer can now understand two colors, black, white, 1, 0. So likewise, you can make this simple and then make computer understand the perception, in terms of measuring the object or any manufacturing item you are doing. It's not necessary you have to provide colors always, right? Colors are can be verified by human in the later quality checks. However, the dimension and precision of the product is very important. So for that, if computer vision can see an object or an image or a video in a black and white format, it is very easy for the computer to you know uh, understand in two different colors. So I am using a gray, as a variable here, and using cv2.cvt color function. And then I'm passing this image variable, and then saying cv2.color underscore bgr to gray. So this basically makes the image into grayscale. So now I'm printing that cv2 image show image off, printing the image again, and then saying, okay, now take that image and then make them as gray. So cv2 underscore image show off gray. So you see, first the image is actually the actual image, original image. It's very colorful, beautiful for human eyes, but machine understanding may be difficult. So now converting them into a grayscale conversion. Now you have only two colors, black or white. So it's easy for computer vision to understand and then identify more granularly. Now we are moving to a Gaussian blurring. Gaussian blurring, this is basically, you can intentionally blur the image and then show, in many video processing or audio processing, or basically, sorry, the image processing, you can blur the image to some extent to reduce the size for various reasons. So here we are using basically you are instructing a computer vision how a image looks like, the same image which you are seeing when it is blurred. You are trying to give a more knowledge and and basically an artificial intelligence to a computer vision, saying this is how the object looks like when it is blurred. So basically the computer vision is trying to learn from it. Okay, even though I'm seeing a little bit blur, but I can still recognize this is how when the particular object or image is blurred. So that's another dimension or variant of the learning. I'm using three variables: blur 1, blur 2, blur 3, and I'm intentionally making the image blur by using a Gaussian blur function in CV2 library, and I'm passing the image variable saying 5 cross 5, 15 cross 15, and 25 cross 25. So, and then I'm printing, the images with blur 1, blur 2, blur 3. So these are like various levels of blur you can expect an object to be, or image to be, or video to be. You can see this is the original image, how beautiful it is, and then now I'm blurring into the first level. So you can see little blurred now, which is basically um, the 5 cross 5, and then next one I am doing 15 cross 15, so a little more blurred, and then little beyond 25 cross 25. So likewise, you can basically change these values and play around and make them blur much further. Let's move to the next function, cropping image. So crop the image. I'm using a crop image variable, and then I'm passing the dimension of the image, height, and then width in the two form, 150 480 and then 150 650. So here I'm showing a cropped image option, and then if I run this, I'm using the cv2.imWrite function to crop the image in this dimension. So you can see the big image above is being cropped into the first half of the image, in a quarter of the image basically. So if I change this 550 and then 750, so you will see the image is a little bigger. So likewise, you can play around these values until the maximum size of the image, which you found in the earlier functions. What is the image dimension? So that's the maximum you could go. If you go beyond that, you're eventually going to fail getting results. So that's the maximum you could go. And then image rotation. So you are basically, assume if a computer vision is seeing only the portion of the image and something else is hiding the view of the camera, for example. So in that sense, you are teaching or training the computer vision. Okay, if something is hidden and you are seeing only portion of it, it's still the same object, same image. And that's how you are training the computer vision. And image rotation, what happens if a object is turned or image is turned for whatever reason? Still, the computer has to understand. So you are basically using the width shape function, and then I'm using some variables here, and then using the rotation matrix in two-dimensional rotation as it's a flat image, and then wrap a function to wrap the image in a different angles. So, and then I'm printing cm2 image show image off, and then image show rotated image. So when I execute this, you will see two different outputs. One is excuse me. One is image show the exact image, and then the rotated image. See how it is rotated. So in case if an object is rotated in a different form, so this is how the computer vision will understand. Then edge detection. So what is the edge of the given image or in the given object? So you are basically generating the edges intentionally and then telling the computer, okay, this is the edge of it. For whatever reason, if you want to identify the edges alone for the measurement, you can say I'm using IM gray and image blur. So I'm using cv2.cvt color function to provide the image I have, and then I'm seeing, color BGR, as you can see, to gray, and then I'm seeing Gaussian blurring the image into 3 by 3. So then I am canning the edge detection, is a canny function where you can make this image blur and then show the edges. So it basically removes all the color from the image and then take only the edges. Then I'm taking the showing the edges separately. So basically it is taking out all the colors other than black and white and then showing the everything in the image in the background as black and then all the edges in white, so that you can detect all the possible edges in that given image. So if you run this, so you will see, so the original image is, all the colors behind is been dark black, pitch black, and then all the edges of the leaves, the petals of the flower is been white. So computer can recognize, okay, this is how the edge looks like, assuming if no color is visible, right? So that's pretty much many functions. You can try out this by referring the existing methods we used, and also make some modifications and run them. You can take the different combinations from the computer vision and add into this and then try executing. It's very useful for any computer vision, particularly in terms of quality checks and all other combinations. Summary, as part of this proof of concept, we have achieved following steps. We learn how to read and display a sample image from Google Drive, and how to identify image shape and resizing, how to convert image to a grayscale and Gaussian blurring, and how to crop a image and rotation and edge detection using a canny method. I hope you enjoyed this video. Thank you so much for watching. Please try out of your own and then share your comments in the video. And don't forget, like, share, and subscribe. Thank you.